Hi, in this video we are going to look at approximations. Then question 1a reads, the mass of a bag of meal is 25 kg. Complete the statement. This side we need to have our lower limit, this side we need to have our upper limit. Now before we even do that, we need to find the absolute error for 25 kg, of which absolute error for our number we know to say it's supposed to be 0.5, or we use the formula n over 2, of which n is the least unit of measurement. Since here is 25, we know very well to say the next number will be 26, meaning we are adding 1 to get 26 over 2. Then when you divide here, half is the same as 0.5 kg. So this is our absolute error. Now how do we find the upper limit? How we find the upper limit is that, so upper limit will be this side, is that we add the true value, which is 25 kg plus 0.5 kg, which will give us 25.5 kg. So meaning here we add plus, okay, we add the upper the original or the given mass plus the absolute error. So meaning our answer here will simply be 25.5 kg. So that is on the upper limit. On the lower limit we subtract the true value minus the absolute error. So here we were adding the true value plus the absolute error to give us the upper limit. For this one, we'll subtract the true value minus the absolute error, of which here it's 25 kg minus 0.5 kg, which will give us 24.5 kg. So meaning here is 24.5 kg. So that is how you answer this question. Okay, we go to B, this question here. Okay, this question reads, that is B, they're saying the length of a line is 8 centimeters. If this is recorded as 8.2 centimeters, this one, calculate the percentage error. Now we know to say percentage error is given by the formula relative error multiplied by 100%. Now do we have our relative error? No. So if we want, we can calculate it just here. If we want, we can calculate it separately. Okay, so let's just go, we calculate it from here. We know to say absolute error is, relative error is absolute error over true value. Okay, this is the formula for relative error. This is the formula for relative error multiplied by 100%, since we want to calculate it at once. So what is our absolute error? Our absolute error, we have to find it. So we know to say absolute error is equal to the modulus of recorded value minus the true value. Okay, now our recorded value is what? Our recorded value, they said it was recorded as 8.2, so meaning here it's 8.2 centimeters minus our true value is 8 centimeters, meaning our absolute error is simply 8.2 minus 8, it is 0.2 centimeters. So meaning our absolute error is 0.2 over the true length, or the true value is 8 okay, multiplied by 100%. Now look at this. For us to simplify this, we can first find the relative error by multiplying by what? Here you have one decimal place, meaning I'm multiplying by 10. Even down, we do the same, multiply by 10. Then it will give us 2 over 0.2 by 10, it's 2 over 8 by 8 times 10, it's 80 by 100%. Then what do we do next? We can just divide like this. Then 2 by 10, or 2 by 2 multiplied by 10, it will give us a 20, okay, over 8, of which now the final answer will simply be 2 by 10. Okay, so our final answer, 8 into 20, we know to say it goes into 16 2 times, remainder a 4, that 4 add a 0, 8 into 40, it's a 5. So this is our answer, simply 2.5%. We go to the last question. Okay, this is our last question. Okay, our last question reads, the length of a piece of wire is measured as 4.5 centimeters. Calculate the tolerance. Now in this case, how do we calculate our tolerance? Okay, how do we find our tolerance? It's very easy. We need to know, if you want, you can calculate by finding the upper limit and also lower limit, then you subtract the two. Or the best way is we need just to know our absolute error. We know to say absolute error in this case for this number, which is 4.5, is given by n over 2. We're just given one value, okay, meaning our absolute error will be equal to, this is 4.5, meaning the next number will be 4.6, meaning the least unit of measurement which we are adding to get to the next number under this one is 0.1. So meaning here we'll put 0.1 over 2. This will be our absolute error, is then going to be 2 into 0, that is 0. 0.2 into 1, that is 0. We add a 0 there. 2 into 10, that's a 5. So it will be 0.05 centimeters. Okay, this is our absolute error. Now, how do you find our tolerance? Tolerance is equal to absolute error, which is the one that you have calculated, multiplied by 2. Then our absolute error, said it was 0.05 centimeters multiplied by what? By 2, meaning our tolerance will simply be 2 by 5, it's 10, so 0 carry 1, 2 by 0, it's 0 plus 1, we add a 1 here, point to this point, 2 by 0 is 0, then the units, it's centimeters. So this is our answer. So the answer is simply 0.1 centimeters. We go to B. How do we find our relative error? Okay, how do we find our relative error? This is very simple also. We know to say relative error is equal to absolute error over the true value. Now, relative error is equal to, what is our absolute error? Our absolute error, we found it was this one here, 0.05. So meaning to be 0.05 centimeters over the true value. The true value is 4.5 centimeters. So what you can do is you can divide the centimeters. The remainder is 0.05 over 4.5. Now, how many decimal places do we have on the numerator? It's 2. So we'll multiply this by 100. even down by 100. Whatever that you do on top, do it also at the bottom. So now this will give us 0.05 by 100. It's a 5 over, what is 4.5 by 100? It's 450, meaning you can reduce this to, or let me write it down here, we'll reduce this to what? 5 into itself, it's a 1 over 5 into 4, it can't go there. 5 into 45, it's a 9. Then 5 into 0, it's a 0. So our relative error is simply 1 over 90, and that's how you solve this question. So overall, this is how you solve the questions under approximations: tolerance, relative error, absolute error. Yeah, so that's how you go about it.